everyone. I'm Pramod Garwal from Team Dynamic. Our topic is predictive maintenance. Many industries struggle with unexpected equipment failures and high maintenance costs. Normally, maintenance happens only after something breaks down, which leads to surprise breakdown and expensive repairs. What we need is a solution that can predict the problem before they happen. This way, we can fix the issues before they cause the downtime and saves our maintenance cost. Our system addresses thus our system addresses those needs by using AI to forecast the potential equipment failure before they occur. It provides the real-time dashboard that shows the current health of all the equipment, allowing you to monitor the status easily. Additionally, it sends the proactive alerts if it detects that something might fail soon, so you can take the action in advance. The system also automatically assigns the maintenance tasks through the mail to the relevant personnel, ensuring the timely interventions. I will first let me explain you the which kind of fault we are covering. We have covered three types of the fault. The very first fault is unbalanced fault. As you can see, this is the simulation of the machines which we have used. The second fault is misalignment fault, and the third fault is bearing fault. I will explain you what is the unbalanced force. Unbalanced. Suppose this is our machine. Suppose this is the motor. This is the shaft. This shaft is being rotated yeah, through this motor at particular frequency. Okay, this is the rotator, unbalanced rotor, which we have added into the shaft to produce the unbalanced force in the machine. Suppose I'm adding some mass here. The- Since the machine was rotating at a very good frequency, and then suddenly I added some mass into it, that unadded mass will produce an unbalanced force into the machine, centrifugal unbalanced force. Due to that force will act outward, and due to that force, these rod get unstable, and it will produce some kind of vibrations. That vibrations are recorded in this sensor, and it is exported to the Excel sheet. Okay, that vibrations can damage your machine. If it is producing very high vibration, it can damage your machine. So this is the first type of fault which we have covered. The second fault is, as you can see, here see, there are two rods. One rod is this and other rod is this rod. They are coupled here. Those two rods are coupled here. Okay. Due to the coupling, what happens? Due to coupling, suppose this rod, suppose I am suppose I am tilting this rod little above than this rod. They are not at the same level. Due to this, due to I have misaligned the rod now. This misalignment will produce some vibrations in the machines, some amplitude in the machine, which causes the damage in the machine. This is the second type of fault which may occur in our system. The third system is bearing. As you know, bearing is an important part of the machine, and the fault in the bearing will cause the damage of the machine. There are three kind of fault which can occur in a bearing. Third one is ball fault. The fault occurred on a ball. The second fault is outer race fault. The fault that may occur in the outer race, and the third one fault is inner race fault. The fault that may occur in the inner part of the Okay, so thus three faults we have included in our system. Okay, so what we have done, let me what we have done, we have thus faults we have to cover. After hitting on the problem statement, we had a picture in our mind that we will cover this kind of fault. But we searched on the internet, we find on the Google and Kaggle, but we couldn't find the data set which we need. So what we have done, we have created our own data set. These machines we have in our laboratories in a mechanical department of our institution. We visited their lab. We asked the teachers to allow us to use this machine. We actually perform we perform the simulation. We perform the experiment to get the readings. I will show you the video also uh, how how we collected the readings of the machine. So this is the machine used in our system. As you can see, we have misaligned this rod by adding the paper. This is the coupling of the two rods. To this, we are getting the frequency at which speed, at which frequency the rod is rotating. Then then see, okay, these readings are collected to the data acquisition system. This is the accelerometer through which the amplitude is recorded. I will show you the accelerometer, our data acquisition system. This is our data acquisition system. These readings are transported to this PC, and through this PC we are getting the all the readings in our in the Excel sheet. Okay, so we prepared, we got the data set, we pre-processed it, and we trained our machine. We have used ANN and CNN model to train our machine. I will explain you. Okay, then okay. So what we have done? So this I will show you this in our system only. Okay, let me go. Let me show you our system. I will start from beginning, from login. First, we have to log in. I have, if you haven't, if you are first time, you can create your account here. And if you have already account, you can directly log in. Suppose I have already account, so I will do login from here. Okay. See, I have successfully logged in. This is our dashboard. We have kept it very simple. We have not make it like have not made it complex. Easy to read, easy to understand, easy to navigate. Okay. Then see, this is our dashboard. Then this is the tab to which we can make the prediction. I have to enter. I have to give the inputs like. Or input. Suppose I'm predicting unbalanced kind of fault. So I have to add the machine ID. Suppose I'm adding M3, machine third. I have to add the frequency through which the machine that rod is rotating shaft. Then I have to enter the amplitude. Amplitude we will got through the that amplitude accelerometer sensor. Suppose it is rotating at the 0.3, it produce vibration of 0.017 mm. Operating hours is like from how long we are using the machine. Every machine have its own lives, and like this machine can be work for 5 years. After 5 years, it may be it will not give better results. It will not give best results. So our machine is being used from last 10,000 hours, 10,006 hours. Okay, then we have temperature. Temperature is the important factor to find the fault in the machine. If every machine have its nominal temperature, like if we are using it in that temperature, it is good. If we are using it above that temperature, it may cause some fault in the machine. So the current temperature of the machine is been taken through the sensor. It is suppose 67 point, suppose 67.17. Okay, radius is the point at which we have added the mass. The point, like we are adding some mass to produce the unbalance in the machine to get the reading. So suppose I'm adding unbalance at 0.05, 0.05. Okay, 0.05 mm. Okay, so I will predict. Just wait, our machine is pre-processing our data, processing our data to get the result for us. We just have to wait for few seconds. See, see, as you can see, what it have predicted the mass which we have added or subtracted. It has predicted the unbalanced force which caused in the machine. It has predicted the lifespan of the machine, like how more hours we can use the machine. This machine can be used for more 2130 hours, and it has predicted the problem like severity, how severe the problem is. It is 5.99 and almost 6. See, I have given the severity mapping here. If the severity value is 0, it is negligible severe. If it is 1, it is minor severe. If it is 2, moderate severe. And if it is 6, it is critical. Like if the problem is very critical, you need to take action right now. and it so see it also shows the alert like a problem highly maintenance is required. See, then we can generate the report also. You can see the report is being generated by the machine. It is like automatic report is generated by the system. In the report it contains the all the information like which machine which you have used, what is the serial number, who is the manufacturer, date of usage. Then again it have the parameters which we have predicted, like frequency was 7.66, the lifespan was 2160. Say it shows kind of fault, unbalanced fault, a shaft unbalanced fault was covered, detected. Then we have date of occurrence, at what time the fault occurred, and we have time of occurrence, at what time the fault occurred. This is the severity mapping. Then it is suggesting it is giving some recommendation or suggestions to do the repairing of the machine. We have also it will give you the maintenance schedule, if the severity is 6, immediate maintenance is required. Okay, then summary, and here are the sign of page of maintenance engineer and all. So this is the automatic report, personalized report for every machine is generated here. Okay, then see, if we have fault in our machine, like if the problem is very severe, then mail will go to our system. I will show you the mail. Alert through the mail is given. Also, alert through the SMS is given. See, we got the mail that dear user, our monitoring system had detected the critical issue in the machine. Maintenance required. I can download the report from here also. Okay, so we have added type of three type of alert system. First is through mail, second is through SMS, third is through on the website only. Okay, see, this is one thing. Then other thing is similarly, this is for the unbalanced. Similarly, we can do it for the misalignment and bearing. And this is another feature in our system. If we don't want to predict for one machine, we have large industry in real time. We have very large industry. We have large number of machines. So we will not every time we will not be entering single value. What is the frequency? What is the amplitude? So we will directly give the readings. In bulk, we will give the reading in the Excel sheet, and it will see. This time I am taking the reading of misalignment. So what I will do, I will get the reading of all the machines in an Excel sheet, and I will give that Excel sheet to the system, and uh, it will predict for all systems. Okay. Uh,
Wait, stop the music.
so now we will go for bulk prediction. Suppose let's go for bearing. Let me choose the file. This is a file. Okay, this is the file. In this Excel sheet we have the data for all the machines in our industry. We can predict in bulk. This is the third type of fault which we have covered in our system. Just wait for a few seconds. Our machine is processing the data and getting the output for us. See, uh, it is producing inner race fault. These are the parameters like maximum amplitude produce, minimum amplitude produce, mean amplitude, standard deviation, RMS value, skewness, and crush factor, form factor. Those are the some factors which we have generated. Now the another feature which we have is analysis. It will show you the visual analysis of our system, how the frequency and amplitude are varying in the machine, how the unbalanced force is varying on the frequency, how the lifespan is varying on the operating hour, how the severity is varying on the operating hours. These are the analysis. It will show you the real time analysis of our machine. Then other thing which we have in our system is dashboard. Suppose I have predicted I got some fault in my machine. Then this is the admin dashboard. Now I want the I want that my team should do the maintenance of this system. Okay, here I have different machines, so I can assign them work. I can assign the work of maintenance to the someone. Suppose this is the M1 machine and we have significant problem in this machine. I can assign the work of maintenance to the some user. Suppose I'm adding the point like now first I will choose the date. Maintenance should be done by 25th, and I will add the comment. What I will add? Suppose replace the shaft, replace the shaft, replace the shaft. Okay. I will add the employee name, or email ID of employee, and I will add the work to be done. Replace shaft by 25th. 25th. Suppose I want to add another employee, I will add the name of that email ID of that employee also. This is the employee ID of another, and help Ganesh. I have added the work assigned to both of them. I will update here. Now they will get the notification of their work assigned by the admin through our portal. Through the mail, they will get the notification. Okay. I will go to the mail and see work is assigned to me. See, I will got the mail that a work is assigned to you. See, dear employee, you have assigned a work to do the maintenance of unbalanced work done. Work to be done. Maintenance date is also given. The report is also given to me. The I can download the detailed report from here also. Now, also, suppose I have assigned some work to some employee and they have done the maintenance. Now I have to analyze how every after every maintenance how my machine is improving its performance. So the data visualization will be done through the analysis step. See, on day on 29th on 9th December, I had three severity in my system, and it got increased on 13th 13th November. After maintenance, it got decreased to two severity. So the visualization for every machine, how the severity over date is varying, will be shown here. This is for machine 1, then this is for machine 2, this is for machine 3, and all. Similarly, for other faults like bearing also, it will show you how the severity is changing on the system. See, here I have plotted the maintenance date versus the thrust factor, form factor, amplitude, and all. So real-time analysis of the machine health will be done through the admin. Okay, and other feature which we have is another information tab. In this tab, we can read the different articles related to maintenance like vibration monitoring and all. So that is our system. So that's all from our side.